Hello everyone, my name is Dormitory. I come from Harbin Institute of Technology, Weihai, and our paper's title is Cylinder Equalization and Raptor Decoding for Underwater Acoustic Communicating. I will introduce my paper follow the orders of the article as the introduction, system model, algorithms, simulation results. And first, I will introduce the first part, introduction. The requirement of marine and development and ocean exploitation. Underwater acoustic channel has attracted increasing attention, but the environment of underwater acoustic channel is extremely complex, which will cause several ISI and low feedback delay. So how to solve such a problem? Equalization is the common method to solve ISI, and the channel coding technology can further improve the performance of BER. In the technology of the channel coding, there is one called photon code, which can generate an infinite string of encoded symbols from a simple source message. It also called as the weightless code. Common photon codes are LT codes and the Raptor code. In Australian study, it has been shown that the combining of LT code and the equalization technology can improve system performance. And to our best knowledge, there is still a lack of research on the joint equalization and the Raptor decoding algorithm. In our work, we will propose a scheme which can jointly realize adaptively equalization and Raptor decoding. The second part is the system model. As shown in Figure 1, it includes transmitter receivers and underwater acoustic channel. In the transmitter, there are two steps as weightless coding and BPSK modulation. The transmitter signal recorded as SN after underwater acoustic channel. The received signal in the receiver recorded as YN. The relationship between SN and YN as follows in Formula 1, which HI is the type of channel response. WN is adaptively white Gaussian noise in the receiver, that is in the joint equalization and Raptor decoding. The equalization, demodulation, and the decoding is an iterative process. Details that we will introduce in the letter. And the Figure 2 is the system model of the transmitter of Raptor code. Contains AODV encoding and LT encoding. The tenor graph of Raptor code as shown in Figure 3. The AODV code consists of the source node and the intermediate node, which the LT code graph considers emitting nodes and the encoding node. The AODV code can be decreased in terms of the spark characteristic machine, which is created at random with the same weight per column and the weight per round as uniform as possible. And the LT code will generate at the following step. Firstly, choose the degree of each encoding symbol randomly according to the degree distribution. And then, select the different improved symbol randomly as neighborhoods of the encoding symbol. and the encoded symbol is the result of XOR of the D. Choose the neighborhood. Before I introduce the joint equalization and the Raptor decoder algorithm, I will take a look at the tunnel graph of Raptor decoding. As shown in Fig 4, the message of information in the decode is denoted by M. The MOR is a message decoding node sent to the intermediate node, and MIO is intermediate node to the encoding node. The MVI is a message variable node sent to the intermediate node, and MV is intermediate node to variable node. According to the principle of ALT encoding and the relationship of the lower likelihood rate, we can obtain the formula of the ALT encoding as shown in the formula 234, where the P1 decoding iteration number of the ALT decoder, the L1 represents the iterated number of ALT decoding in progress. Q represents the number Q global denoting iteration. Similarly, we progress the decoding the LDBC code as follows, and the L2 is the decoding iteration of LT decoder. MVC can be iterated by the following formula. While P2 iteration of the LDPC decoder, the expression information of the variable node in the LDPC decoder is provided as the provided information for the intermediate bit in the LT decoder in the next global iteration as shown in the formula 8. After G iteration of the global decode, the message to variable node corresponding to the information bit is shown in the formula 9. After the hard decision on every information bit is made to record the social message, the software information of the important data can update the process of the Raptor decoding as a formula 10. Then we try to establish the interfering symbol to cancel the resistance RSI by modulation the software information of those symbols from the last type of Raptor decoding iteration. Thus, the symbol can be estimated as formula 11. To minimize the mini-score errors, MSE, between the equalizer output and the transmitter system. After all the information of the symbol from the decoder is obtained, the equalization can be updated as the follows. In the part 4, we use the Beer-Hall model for the underwater acoustic channel simulation, and we perform 2 global interaction with 7 LT encoding interaction and 3 LDPC decoding interaction per global interaction. The effect of interaction of the BER performance for Raptor code with different SNR is shown in the Fig 6. It can be seen that Fig 6 that with the increasing of the interaction number, the BR decrease, and the eventual tend to be flat. As the interaction number increase, the BR performance is improved significantly in the 13 interaction, and then tend to be stable. So in the following simulation, we set the interaction number as 13. In the fixed 7, give the BR comparison of different skin, including the ARD tuber, the separatist skin, and the JRD. It observed that the JRD achieved better BR performance than the separatist skin. This is because the interaction process can improve the correctness of feedback information. It also observed that when the SNR is greater than 7 dB, the BR performance of JRD is significantly better than the LT tuber. This is because that Raptor decoder outperforms the LT coding. In the iterative process, the feedback solved information is more accurately. With the iteration number increase, better BR performance can be achieved. The figure 8 shows that the relationship between the decoding success rate and the code redundant. It can be seen that under different SNR for successfully decoding, the number of symbol requests by JRD is less than the by LT tuber. This means that the redundancy required for successful decoding with JRD is smaller. It can be also observed that as the SNR increase, the random requests for successful decoding generally decrease. When the decoding success rate is higher than 99%, the performance numbers of the received symbol we can show in the table 1. In this, the number of received symbols is given when the decoding success rate reaches 99%. In the simulation, the SNR rise from 3 to 8. It can be seen the comparative to the LT tuber ERD used the fewer encoded symbol to recover the original information, which means that the redundancy rate of JRD is observably lower. And this is all I want to say. Thank you for listening.
Design of wireless communication system for CNC machine tools. The machine tool is an important element of the integration of advanced manufacturing technology and manufacturing information. It is an indispensable complex production tool for the development of the machine manufacturing industry and the entire industry. It is not only an element of productivity, but also an important commodity. To a central extent, the development and innovation of machine tools reflect the main trends of processing technology. Modern CNC machine tool comprehensively applies the latest achievements in mechanical design and manufacturing process, computer automatic control technology, precision measurement and detection, information technology, artificial intelligence, and other technical fields, and will develop toward to trend of high speed, precision, compound, flexible, extreme, and so on. As automation of manufacturing process increases, machine tools are required not only to complete the usual processing functions, but also to have functions such as automatic measurement, automatic loading and unloading, automatic tool change, automatic error compensation, automatic diagnosis, wire feeding, and networking. The intelligence of machine tool numerical control system is the general trend, and the proportional software in numerical control system is increasingly day by day, so that the numerical control system not only controls the machine tool movement, but also provides many possibilities for optimized design and rational use of the machine tool. In recent years, in order to better meet the high-speed, high-precision, compound, intelligence, and environmental protection requirements of machine tool users for CNC machine tools, domestic and foreign CNC machine tool companies have continuously developed various types of CNC machine tools with intelligence functions, especially with the development and application of machine tool design technology, Internet and information technology, and artificial intelligence technology. CNC machine has gradually shown a trend of networking and intelligence, and the intelligence functions of CNC machine tools have become more and more mature. There are 4 parts as follows. The first part is researching background. CNC machine tool is a typical mechatronics product. It can solve the problem of precision, complex and small batch parts processing. As a cornerstone of modern industry, The machine tool industry is an important reference for measuring the industrial level of a country. The state monitoring system of the control machine tool can promptly alarm the abnormal work of the machine tools, effectively avoid the occurrence of machine failure. Currently, most monitoring systems use independent network groups. The form of the Internet has caused a lot of waste of human resources. In order to greatly improve the network efficiency, this paper proposes a new type of CNC machine tool system. The central control device and the machine tool are separated, which can carry out one-to-many centralized management. In addition, in order to achieve the goal of mobile management, this paper also proposes an embedded CNC handheld terminal program, which can assist the work of CNC machine tools and save the labor cost. The second part is design of wireless control system based on Zigbee network. The central control device is no longer connected with CNC machine tools, but wireless transmission information through Zigbee network can realize remote control. Secondly, a control device can control multiple CNC machine tools at the same time, saving resources and realizing centralized management. In addition, with the help of Zigbee network, the whole system can realize two-way communication, which can not only control the machine tool but also monitor the working state of the CNC machine tool. The information is sent to the destination CC2530 in a wireless way. After receiving the information, the receiving board still needs to carry out some necessary processing, and then in the form of digital electrical signals sent to the CNC machine to a PLC to complete the processing task. The third part is the handheld terminals used in CNC equipment. First is Ubiquitous startup program. The second is Linux kernel tailoring and system porting. The third is writing application software. The last is wireless network car driver transplantation and configuration. A bootloader program is required to start a Linux system, which means that a bootloader program is run after the chip is powered on. This bootloader program will first initialize DDR and other peripherals, then copy the Linux kernel from flash to DDR. And finally starts the Linux kernel. Linux kernel tailoring. First, copy the Linux 3.0.35 source code compressed package to the Ubuntu home directory and enter in the terminal. Finally, enter the following command. Complete the cross compilation of the modified kernel and obtain the kernel file image. The compiler uses ARM Linux GCC 4.5.1. Use BusyBox to make root file system with static compilation method. Use the cross compiler to compile the kernel. Use the DNW tool to download the Linux kernel image. We need to add Wi-Fi driver source code to the Linux kernel and then configure it through the graphical interface and choose to compile it into a module. Execute the making menu config command to open the Linux kernel configuration interface, and then select the following path to compile the RTL81 driver into a module. Once the machine tool runs, it will return a success or failure command, which is received by the hardware development board to inform the user of the operation result. If necessary, the corresponding interface program can be developed. The machine tool can be directly controlled on the development board to ensure instruction can accurately enter the CNC machine tool. The fourth part is conclusion. The Internet of Things numerical control technology add new vitality to the production of mechanical automation control system. Not only promotes the level of automation, but also further expands the application level of Internet of Things numerical control technology. This article uses the Internet of Things numerical control technology to improve the stability and accuracy of the mechanical automation control system. It can effectively integrate the advantages of the Internet of Things numerical control into mechanical automation control system. Thanks.
Hello everyone, I'm Gui Tim. My teacher is Lucy. Today I would like to present my paper, Energy Efficiency Optimization for Subcarrier Allocation-based SWIPT in OFDM Communications. I would like to present this paper from the following 4 parts. Firstly, the system model. As shown in this figure, it was composed of the transmitter and the receiver, and both were assumed to be equipped with a single antenna. During transmission, the bandwidth of the link from transmitter to receiver was evenly divided into K subcarriers. All these subcarriers combined into a set K. We denoted the channel power gain of subcarrier K as HK, and assume that the transmitter already knew about it. Slow fading is considered in this paper, and all coefficients associated with channel were assumed to be constant during one transmission period. During transmission, all subcarriers were divided into 2 sets, which were GI and GE, and the receiver used subcarriers in GI to decode information and used subcarriers in GE to harvest energy. Then the achievable rates R and the harvested energy Q can be formulated as the following 2 equations. Kc here denoted the energy conversion efficiency of equation Q, and the total power consumption of the system can also be calculated. Here, PC denoted the fixed power consumption of hardware circuits, and the first 2 parts of the equation were the total transmitted power, and the subtracted part represented the collected energy, which was Q, and sigma k squared is neglected here. The energy efficiency was expressed as a ratio of total rate to the total consumed power. Then the energy efficiency of the proposed system can be given as this fraction. With the constraints of the gather rate and the maximum and the minimum energy, harvested energy, and the total transmitted power budget, the optimization problem can be formulated as follows. Our aim is to maximize energy efficiency and these three conditions, and these three constraints. Now let's come to the second part. In order to maximize the energy, we need to find the optimal solution to optimization problem. Firstly, we optimize the power allocation for given site allocation. Secondly, we optimize the site allocation. And finally, the joint optimization is carried out to obtain the optimal solution. But first of all, it can be observed that the regional objective function is a friction, which is difficult to solve directly. So we use Q star to convert the original friction to a subtraction. Therefore, the original optimization problem can be rewritten in this form. Here, the three constraints still remain the same. Now we can use Lagrange dual function and Dinkelbach algorithm to figure out this problem. The Lagrange dual function can be described as follows. The dual optimization problem can be described as this form. Since the dual function is convex, we can obtain the optimal variable beta through the subgradient additive method. The subgradient of dual optimization problem can be formulated as follows. The optimal beta can be obtained from this equation. During the additive, we can find out the optimal dual variables when converged reached. With the following two steps, we can finally achieve the optimal P and G with a given beta. With a given G, we can apply standard Lagrange method and KKT conditions to optimize power distribution P. When subcarrier K belongs to Gi, the power Pk can be obtained from this equation. Otherwise, Pk is equal to Pmax or Pminimum. Here, Pmax and Pminimum denoted the maximum and the minimum power constraints for each subcarrier respectively. Substitute the formula of P star into Lagrange function. The original function can be rewritten in this form. Here is the Fk star's equation. We can find from this Lagrange function that on the right-hand side, only the first part Fk star is related to subcarrier set Gi. So Gi can be optimized by finding the set that maximizes the Lagrange function. Then also, the optimal GI can also be obtained through this subtraction. The optimization of subcarrier and power distribution can be solved from algorithm 1, and the maximum energy efficiency can be obtained by utilizing Dicoding iterative algorithm, which can be summarized in algorithm 2. In algorithm 2, when the convergence reached Q star is the maximum energy efficiency. Now let's come to the simulation results. This figure shows the distribution of power and subcarrier under certain conditions. Here, subcarrier number equals to 32. Equal to 32. Here are the comparison of energy efficiency and the achievable rate versus P of different algorithms. P here denoted the total transmitted power budget. In algorithm 1, the total transmitted power is divided into M components on average. In the fixed radio, the power allocation on each subcarrier is split into two parts, respectively for harvesting the energy and decoding the information. In algorithm 2, all subcarriers are randomly divided into two sets, and each set has the same number of subcarriers. The sets are fixed and the water filling method is utilized for power allocation. Subcarriers in different sites will be respectively used to decode information and harvested energy. It can be clearly observed from figures that our proposed algorithm performs better than algorithm 1 and algorithm 2, and algorithm 2 is superior to algorithm 1. We can know that in algorithm 1, all subcarriers, regardless of channel gain, are used for transmission, so that the power will be wasted on some poor subcarriers. In algorithm 2, the subcarrier set is not optimal, which will inevitably cause power waste even if the power is allocated by water filling algorithm. And since the condition of subcarrier will be judged before power allocation, the subcarrier with poor channel condition will not be used for transmission. Therefore, algorithm 2 wasted less power than algorithm 1 and performed better. Our algorithm optimizes both subcarrier and power allocation, and thus performs best among the three algorithms. Finally, I would like to make a conclusion with this presentation. In this paper, to achieve communication, we started an energy efficiency optimization scheme based on the OFDM SWIPT system, where no power splitter or time switcher is required at the receiver. In the system, all received subcarrier was split into two sets, and the subcarriers in the two sets were utilized for energy harvesting or information decoding respectively. In order to achieve maximum energy efficiency, while satisfying certain constraints, a dual-layer iterative joint allocation algorithm was proposed. The simulation results show that our proposed algorithm achieved superior energy efficiency compared with the other two algorithms. That's all my presentation. Thank you for your listening.
Hello everyone, my name is Zhou Wenjie. I come from School of Electronics and Information Engineering, Harbin Institute of Technology. The name of my article is Comparative Analysis of Communication Links Between Earth Moon and Earth Mars. Next, I will describe my article from 5 aspects. The first, introduction. The second, the similarities and differences of the environment. The third, analysis and simulation. The fourth, the characteristics of radio wave transmission. And the last, conclusion. Part 1, Introduction. Deep Space Communication Missions. First, many space agencies and researchers have been making efforts in the long-distance weak signal transmissions enhancement. Second, large-scale antenna array. The third, because of the slowly development and the great difficulties of such physical solutions. It is important for us to pay more attention on the interplanetary networking. The last, derived from the needs of national development strategy, there might be more and more robot-manned spacecraft to explore further space in the solar system. Many technical difficulties in the communication channel, low coverage and huge loss due to the distance and the impact of cosmic environment. The deep space exploration missions marked by the exploration of Moon and Mars has greatly improved the requirements for the reliability and real-time performance of the ground-air communication. The adjustment capability of the multimedia type service, the processing capacity of the transmitted data, and the throughput rate. Analyzing the basic characteristics of the link channel and studying the specific problems of near astral communication will be the necessary foundation for the development of deep space communication research. Part 2. The similarities and differences of the environment. First, the distance between the Earth and the Moon is much shorter than the distance between the Earth and Mars. Second, the communication delay between the Earth and the Mars has reached several minutes or even more than 10 minutes. But between the Earth and Moon, it is relatively small, only about 1 second as maximum. Third, in addition, the surface of Moon is not covered by the atmosphere, so there will be no atmospheric fading during the transmission of radio waves. There are more seas and land on the surface of Moon, and there are no mountains, lakes, and oceans. The environment is relatively simple. Part 3. Analysis and simulation. Atmospheric loss in the Mars channel. The formula for calculating the loss coefficient of dry air is as follows, where F is the frequency, the unit is GHz, P is pressure, the unit is HPA, T is temperature, the unit is Celsius, RP is P in addition to 1013. RT, rho is water vapor density. The unit is gram per cubic meter. The relationship between atmospheric loss coefficient and frequency. In the picture, the loss coefficient of Martian atmosphere is small compared to the Earth's atmospheric loss coefficient, and the loss caused to the communication link is basically relatively smaller. At the same time, the curve of the Martian and the Earth's atmospheric fading coefficient has reached an extreme value around 22 GHz. Sandstorm loss in the Mars channel. The characteristic fading of the dust on the surface of Mars is as follows. From this figure, we can see that as the frequency increases, the loss caused by the Martian sandstorm will also increase. And when the frequency is kept constant for larger sun's particular radius, the sandstorm characteristic fading value will also be bigger. At the same time, the change of the communication distance will also affect the value of sandstorm fading. Part 4. The characteristics of radio wave transmission. We mainly analyze the loss changes of reflection and diffraction. Let be the scattering loss coefficient with the expression is as follows, where delta H is the standard deviation of the undulations on the surface of the star, and J lin is the first kind of zero-order Bessel function, and phi represents the glancing angle. If glancing angle is set to 10 degrees, the value of the scattering loss coefficient can be estimated. In the figure, it can be seen from the curve that the frequency increases. The scattering loss coefficient decreases to near zero. At the same time, for larger surface function standard deviation, the terrain is not flat and the energy of radio wave scattering is more. When the communication distance does not exceed the sum of the maximum line of sight propagation distance and half of the half shadow width, the loss of long distance propagation and diffraction can be expressed as follows, where fx is the distance gain term and gy is the height gain term. The expressions are as follows. Among them, the calculation formula of x and y is. In the formula, where is the equivalent radius, d is the transmission distance, dirt is the ground conductivity, h is the corresponding height, k is the normalization factor, b equal beta y. And for horizontal polarization, the parameters beta and k have expressions as follows. If the height of transceiver is 2 meters, The equivalent radius is 100 kilometers, and the frequency of the communication wave is 1000 MHz. Taking the lunar surface as an example, under horizontal polarization conditions, the lunar surface conductivity is 3. Relatively permittivity is 3. Lunar radius is 1,738 kilometers, and in the diffraction range of 1,000 meters to 8,000 meters. The long-distance propagation around the lunar surface can be obtained. In the picture, as the transmission distance increases, the loss of the diffraction section will gradually increase. At the same time, by comparing the curve changes of the diffraction loss at several different frequencies, it can be found that the low-frequency radio waves are affected when the distance is closer, the loss is greater, and when the distance continues to increase far enough, the loss of higher frequency waves will exceed that of lower frequencies. The last part, conclusion. This paper mainly considers the characteristics of the Moon and Mars channels, gives the performance simulation results of the communication links in the Ka frequency band and lower frequency bands, and summarizes the relevant characteristics of the deep space channel. This is the end of my thesis. Thank you for your watching.
Ladies and gentlemen, good morning. It's very pleasure indeed for me to be able to attend this meeting. Today, I would like to present my paper, Compact Miniature MIMO Area Antenna Towards Millimeter Wave. First of all, I want to introduce myself. I come from Harbin City Technology, Harbin City, China. The content is listed as follows. I will introduce our subject through the following 5 parts. Part 1 is introduction, Part 2 is main work, Part 3 is the first antenna we designed, that is 77 GHz in elliptical patch microstrip feed area antenna, and the fourth part is 77 GHz series fed MIMO antenna with chip-shift distribution, and the last part is conclusion. MIMO technology, we all know that it can not only enhance the transmission efficiency, but also reduce the transmission power, and it can increase the spectrum efficiency, and the channel's capacity increases linearly with the increase of number of antennas, so MIMO technology can effectively increase the spectrum not only spectrum efficiency but also channel capacity without increasing the bandwidth or the total transmission power. MIMO technology is one of the core technologies of the fourth generation communication technology, and in the future it will also be a key technology for fifth generation communication. At present, the communication frequency band is gradually developing towards the millimeter wave band. Applying millimeter wave technology by increasing the spectrum bandwidth can evaluate the shortage of frequency sources and increase the information transmission rate. Due to the high frequency band and few interference sources, the anti-interference ability of the channel can be enhanced. The application of millimeter wave antennas greatly reduces the size of the antenna compared with microwaves, and so realizes the miniaturization of the antenna. A major problem in MIMO technology is the design of the antenna. On the one hand, MIMO antennas will develop in the direction of miniaturization, and on the other hand, in order to realize the advantages of MIMO system, the antenna needs to have low compelling. And researchers use a few methods to improve isolation, and they usually add decoupling structures between antenna elements, including parasitic elements, defective ground structures, and EBG structures to improve the performance of MIMO antennas. For example, on the picture on the left shows that the two split rings are set at the outer of the antenna, which can provide enough space to develop decoupling structures between the two elements, and a fork-like slot is integrated into the middle of the ground, and the two L-shaped slots are designed at each side of the ground plane. And on the picture on the left shows that they use an EBG structure to improve the isolation. Based on the appearance research results, the MIMO antennas designed in our research are in the millimeter wave band, and the resident frequencies are all near 77 GHz. We mainly discussed the decoupling of antennas in MIMO system. The first area antenna we designed is microstrip feed patch MIMO antenna, which unit is an elliptical patch, and we use a decoupling branch to provide a high isolation better than -15 dB. And the second antenna we designed meets the chip-shift distribution with series, a resonance feed. And we use a 1 by 16 line array as the MIMO antenna unit And we finally increase the line area space to achieve an isolation of less than -20 decibel. And now let me introduce the first antenna, that is a 77 GHz elliptical patch microstrip feed area antenna. And this is the structure of the antenna. And we use microstrip feed, and the antenna unit is an aural patch. And the dimensions are as follows. And a compelling branch is added between two units, and this is as dimension. Blue structures are mantle radiation patches, and the yellow structure is 0.1 mm thick at first for the electric board, and the distance between the two elements is 0.5 wavelength, and the resonance frequency is 77 GHz. The antenna covers the frequency band of 76.4 to 77.6 GHz, and the isolation reaches -18.5 decibel. Before adding the branch, assuming that the unit spacing is A, and here we analyze the return loss and isolation of MIMO antenna with a region from 1.984 mm to 3.986 mm, and we can see that the resonant frequency is maintained at 77 GHz, and the bandwidth doesn't change significantly. And the results on the left show that the isolation increases with distance, and we can see that when the distance is wavelength, the isolation reaches -25.5 decibel. But when the distance is 0.5 wavelength, the isolation is just -11.2 decibel, and now the isolation doesn't achieve good results. And because our goal is to achieve high isolation and miniaturization, so we set the antenna spacing to 0.5 wavelength, and then we design the decoupling structure like this, and we analyze the isolation before and after adding the decoupling branch. And we can see that after it has been seen that the decoupling branch greatly improves the isolation. And before adding the branch, and after adding the branch, it turns to be -18.5 decibel, and now it is lower than -15 decibel. So now it's the MIMO antenna has a good performance, and this is the gain of the MIMO antenna. The gain reaches 5 decibel. In this section, we design a 77 GHz area antenna with microstrip feed, and an elliptical patch used as the antenna unit. We discuss the influence of the distance between the two elements on the performance of the MIMO antenna. Finally, the distance between the two elements is determined to be 0.5 wavelength, and we designed the decoupling branch to increase the isolation between the units. The antenna covers a frequency band of 76.4 to 77.6 GHz. The isolation in the frequency band is less than -15 decibel, and the system has a good performance. And this is the second antenna. It is 77 GHz series-fed MIMO antenna with chip-shift distribution. And this is the structure of the antenna. A 1/16 area is used as the MIMO antenna unit, and purple structure is a mantle radiation patch, and the green structure is a 0.254 mm thick RO303 dielectric board. and the excitation amplitude of each array element obeys chip-shift distribution by adjusting the width of each array element to meet the chip-shift distribution. The MIMO antenna covers the frequency band of 76.1 to 79.4 GHz with the gain of 19.44 dB, and the oscillation reaches minus 35.2 dB. Here's the unit of the MIMO antenna. We can see that the antenna structure is symmetrical, and by calculating the weighted value of chip-shift current with n equals 8, the radiation power ratio of each element in the linear array is as follows, and as long as the width ratio of each element meets the above ratio, then the radiation power ratio of each element can be guaranteed, and the width of all the microstrip patches is calculated according to the width of the central patch, and this is the central patch, and the parameter of the central patch W1, and the width of other units are W2 to W8. In order to ensure that the faces of the units are the same, and the length of each radiating unit and the length of feeder between the units are half of the wavelength, just 1.1 millimeter. The width of the feeder line is 0.12 millimeter. A quarter wavelength independence commenter with a width of 0.3 millimeter is added to the feed end of the linear array. And then two array elements are placed in parallel on the dielectric board with the area of 6 by 36.5 millimeter, and the distance between the two elements is now 0.36 wavelength. Here is the simulation result of the oscillation, and we can see that nearby 77 GHz, and the S12 is around 14 dB. At 77 GHz, it's just minus 14.1 dB, and the result doesn't meet the requirement. So the next step is to increase the oscillation. And first, we used the compounding branch. And here are the simulation results, and we can see that after adding branches, the branches increase the return loss at 77 GHz and increase the bandwidth by 20%. As for the oscillation in the 70 to 80 GHz frequency band, the S12 decreases significantly near three frequencies, 70.5 GHz, 72.8 GHz, and 75.8 GHz. But at 77 GHz, the oscillation is just 30.03 dB, and now it haven't reached the desired effect. So we tried another method, that is to slot. And here is the return loss, and here is the oscillation. And still, we can see that after slotting, the oscillation is at 77 GHz. The oscillation is just about minus 12.5 dB. And the result doesn't meet the requirement. So finally, we increased the unit distance to 0.75 wavelength. And the simulation results are as follows. And figure 21 shows the return loss of the MIMO antenna with a bandwidth of 3.3 GHz, and the frequency band is widened compared with the line area spacing of 0.36 wavelength. And there are two resonant frequencies of 77 GHz and 78.5 GHz in the frequency band. And figure 22 shows that after increasing the unit distance, the coupling between the linear areas is greatly reduced. And we can see that at 77 GHz, the S12 parameter reaches minus 35.2 decibel. And here, the MIMO antenna finally has a good performance. So this is the gain after increasing the unit distance, and which reaches 19.4 decibel. In this section, we design a series-fed microstrip area antenna that meets chip-shift distribution. The antenna area consists of two 1/16 series-fed units. The influence of the sloping and folded T-shaped compelling branches are studied. Finally, we increase the isolation by increasing the distance between the antenna elements. The antenna covers a frequency band of 76.1 GHz to 79.4 GHz. Here are the two frequencies of 77 GHz to 78.5 GHz in the frequency band. And the gain is 19.4 decibel, and the isolation is greater than 20 decibel. And to summarize, we focused on the issue of millimeter wave MIMO antennas. First, a MIMO area antenna with 77 GHz microstrip feed is designed, which unit is an elliptical patch. A decoupling branch is added in the middle to improve the isolation. As a result, it reaches less than minus 15 decibel. Then a MIMO area antenna with a frequency at 77 GHz that meets the chip-shift distribution is designed. We use series resonant feed, and the line area is used as MIMO antenna unit. Sloping and decoupling branches doesn't improve the isolation of the antenna. Finally, we increased the line area spacing to achieve an isolation of less than minus 20 decibel. The gain reaches 19.44 decibel, and the isolation reaches minus 35.2 decibel. Okay, the above is the content of our research. Ladies and gentlemen, it's been my pleasure to show you our research. Thank you very much for your care and attention.
Hello everyone. The title of my presentation is Adaptive Technologies of Hybrid Carrier based on weighted type fractional Fourier transform, phasing coverage, and spectral efficiency balance. The presentation is divided into 5 sections. The first part is the research background. High-speed communication can be achieved easily using multi-carrier scheme such as OFDM because of its high throughput. Nevertheless, OFDM signals have the problem of high PAPR, and it is difficult for OFDM scheme to realize long-distance transmission. On the other hand, the single-carrier signals have low PAPR and wide coverage can be realized easily. Considering the characteristics of OFDM and SC schemes, this paper combines the switching of carrier schemes with AMC and power control to maximize system throughput, and the proposal of HC communication system based on WFRFT can make the integration of the two schemes possible. Second, the HC system based on WFRFT will be introduced. The HC is composed of SC and MC components, and the coefficient alpha determines the proportion of SC and MC in the HC system. The expression of alpha order WFRFT is as follows. The former xn is the data information to be processed, and the latter xn is the discrete Fourier transform of xn. The expression of alpha is as follows. The carrier scheme is changed by adjusting the coefficient alpha. That is, the system mentioned above is MC transmission when alpha equals 1 and SC transmission when alpha equals 0. When alpha is between 0 and 1, it is HC transmission. The transmitter and receiver structure diagrams in the flat fading channel are given in figures on the right. There need to be frequency domain equalization operation at the receiver in the frequency selective fading channel. Next, the relationships between coverage and spectral efficiency in the flat fading channel will be introduced. The figures shown are the PAPR curves of HC system with alpha from 0 to 1 in steps of 0.1 when the constellation mapping methods are 4-com, 16-com, and 64-com respectively. The number of subcarriers is 512, and the oversampling factor is 8 in the simulation. The table represents the PAPR of these 3 typical carrier schemes. When alpha changes from 1 to 0, the PAPR characteristic of the HC signals transforms smoothly from that of OFDM to SC. When the signals have a high PAPR value, the power amplifier can only process it by input back off to ensure that it doesn't enter the nonlinear region. This equation is the definition of the IBO factor, where the PSAT dB and PAV dB are the saturation and average power of signals sent to PA respectively. In order to ensure the probability that the output signals occur non-linear distortion less than a certain threshold, the IBO cannot be lower than the corresponding PAPR 0. After the power backoff, the average transmission power can be expressed as PT equals Pmax minus IBO. This paper assumes Pmax equals 35 dBm. The maximum average transmission power refers to the transmission power under the condition of IBO equals PAPR 0. Then, we need to calculate the received power PR and the signal-to-noise ratio SNR to select the optimal MCS for user equipment at each distance. PR is defined as the equation In the equation, the second term was the free space electromagnetic loss, and the third term was propagation loss. The received SNR is calculated by the received power PR, single sideband noise power spectral density, and the system band width. Then we will introduce the relationships between coverage and the spectral efficiency. The MCS selected in this paper are shown in the table. The figure shows the block error rate performances of different MCS in the flat fading channel. We can find that the BLER performances reduce gradually from MCS1 to MCS6, and the abscissa in the figure is the ratio of EB and N0. However, the SNR calculated from the received power is the ratio of ES and N0, and the equation shows the conversion method of the ratio of ES and N0 and the ratio of EB and N0. This paper uses BLER equals 10% as the standard to delimit the switching thresholds of the MCS. The results are shown in this table. Suppose that the three carrier schemes are all transmitted with their MATP, and the MATP values of different carrier schemes with different modulation schemes are shown in the table below. Taking the IC scheme as an example, the received SNR under different modulation schemes and the selected MCS are shown in this table. According to the same processing method, the relationships of the HC and MC schemes can also be calculated, and the results are shown respectively. The abscissa is the distance from UE to the base station, and the ordinate is the spectral efficiency. It can be seen that the IC scheme has the largest coverage area of 850 meters. The MC scheme has the smallest coverage area of 650 meters, and the HC scheme has a coverage area of 750 meters, which is between that of SC and MC. Through the above analysis, the conclusion can be reached. The UE can maximize system throughput through the switching of the MCS for a given carrier scheme. In the flat fading channel, if the UE adopts the SC scheme, there is no need to change the carrier scheme, and the SC scheme transmission can obtain the best performance. If the OFDM scheme is adopted, the PAPR performance can be improved through WFRFT pro-coding to obtain the same coverage as the SC scheme. Fourth, the switching strategy of carrier schemes and MCS under power control in the frequency selective fading channel will be analyzed. The calculation process of power control parameters is shown in the figure. Start from 100 meters. Select the SNR switching threshold of the MCS with the highest spectral efficiency, that is 23.59 dB of the MCS6. The transmission power is calculated using this equation. Then, judge whether the PT is greater than the MATP of the MC scheme under this modulation scheme. If less, PT is the power control parameter at this distance, and continue to use the SNR at the next distance until the calculated power is greater than the MATP of the MC scheme under this modulation scheme. Otherwise, the SNR switching threshold of the MCS with the highest spectral efficiency in the remaining MCS is selected at this distance. After switching to a new MCS, continue to perform steps 2 and 3 until there is no MCS with lower spectral efficiency. Use PT as the power control parameter at this distance. Continue to use the SNR at the next distance and calculate PT. Judge whether PT is greater than the MATP of the SC scheme under this modulation scheme. If less, PT is the power control parameter at this distance, and the SNR will continue to be used at the next distance until the calculated power is greater than the MATP of SC scheme under this modulation scheme, then end the process. Finally, the calculated power control parameters are shown in the second column of this table. In order to meet the requirements of the actual system better, the parameters in the second column are rounded as the integer multiple of 1.5, and the rounded results are shown in the third column. It can be seen that the power control parameters drop at some distances, such as 250 to 300 meters, because of the switching of the MCS. Next, the simulation conditions in the frequency-selective feeding channel are shown in the table. The figures on the left shows the BLER performances of 4-com under ZF and MMC equalization. BLER performances of 16-com and 64-com are also simulated with the same parameters. Then, the SNR switching thresholds of all MCS can be obtained. The table above is the SNR switching thresholds under ZF equalization, and the table below is under MMSE equalization. We propose a new uplink selection strategy of the carrier scheme and MCS based on the previous work. This strategy considers the PAPR, BLER of the signals and the power control parameters. Firstly, use the power control parameter as the transmission power and use the equation to calculate the received SNR at each distance. The received SNR calculated from the power control parameters is shown in the table, where the second column is calculated according to the unrounded power control parameters, and the third column is calculated according to the rounded power control parameters. Starting from 100 meters, select the schemes that meet the SNR and MATP requirements at this distance. Among them, meeting the SNR requirement means that the switching SNR of the MCS needs to be less than the received SNR at this distance, and meeting the MATP requirement means that the MATP of the scheme needs to be greater than the power control parameter. Judge whether there is a scheme that meets the requirements. If not, end the process of this strategy. If so, judge whether there is more than one that meets the requirements. If only one, use the scheme at this distance. Otherwise, the scheme with the lowest SNR switching threshold is selected among the schemes with the highest spectral efficiency. Follow step 2 and 3 at the next distance until the schemes at all distances are selected or no scheme meets the requirements at a certain distance. Taking the SNR calculated according to the unrounded parameters as an example, the received SNR is 23.59 dB and the transmission power is 8.05 dBm at 100 meters. There are 15 schemes which meet the requirements of SNR at MATP and only one scheme with the highest spectral efficiency, that is, the MC scheme with MCS 6. Finally, the switching results under ZF and MMSE equalization are shown respectively, where the second and third columns are calculated according to the unrounded power control parameters, and the fourth and fifth columns are calculated according to the rounded power control parameters. The difference between the two is that the UE adopts the MC scheme at all distance under ZF equalization, while the UE adopts the MC scheme with high-order MCS at near distance and the SC scheme with low-order MCS at far distances under MMSE equalization. The reason is that the SNR gain brought by the low PAPR performances of the SC signals is not as large as that brought by the BLER performances of the MC signals for low-order MCS under ZF equalization. The SC scheme outperforms the MC scheme and the low-order MCS, and its MATP is higher when MMSE equalization is adopted. Thus, it is used at long distance. The HC scheme hasn't been adopted under ZF and MMSE equalization, which shows that the HC scheme cannot achieve the optimal performance of the spectral efficiency and coverage in this scenario, and the system can only switch schemes between SC and MC. Finally, the conclusions are reached. From the analysis in the flat-feeding channel, we can find that the UE can maximize system throughput through the switching of the MCS for a given carrier scheme. If the OFDM scheme is adopted, the PAPR performance can be improved through WFRFT pre-coding to obtain the same coverage as the SC scheme. In the frequency selective channel, this paper takes power control into consideration, and we can find that the UE adopts MC scheme at all distances under ZF equalization. The UE adopts MC scheme with high-order MCS at near distance, and the SC scheme with low-order MCS at far distance under MMSE equalization. The HC scheme cannot achieve the optimal performance of the spectral efficiency and coverage in this scenario. Thank you for listening. My presentation is over.
Hi, this is Zhongda Xia from Harbin Institute of Technology, and I will be presenting our paper towards knowledge-driven mobility support. This is the outline of the presentation. First, we introduce the motivation of this research and introduce some research background, and then propose the knowledge dimension in mobility support. And then introduce our evaluation framework, and finally experiment results and a conclusion. So our motivation, we have two main motivations. First, the existing solutions have already exhausted the design choices for providing mobility support, and it's hard to achieve new breakthroughs in performance. So we want to explore new ways to design mobility support solutions, for which we have proposed the new design space, the knowledge dimension. For second motivation is to evaluate the mobility support performance of different approaches across architectures like IP and NDN is a complicated and time-consuming job. So we would like to propose a general approach for evaluating mobility support performance across different architectures. So beta research background. We have depicted the mobility support solutions based into a two-dimensional space. The mobility support problem can be summarized as how to conduct seamless communication with network entities whose network location constantly changes. And the current design space can be separated into two dimensions. First, the host dimension. Along this dimension, different solutions employ an intermediate to track the location of mobile entities. And along another dimension, the data dimension, when data can be separated from the producer, such solutions try to make data constantly available by moving or disseminating them. And in each dimension, the solutions can be categorized into several basic mobility support approaches, as shown in this picture below. This is a more detailed introduction of the approaches along the two introduced dimensions. Along the host dimension, there are four types of approaches, which we'll introduce in more details later. First, the proxy-based approach. An indirection point, i.e. the intermediate used to store the locator of the mobile, and later uses the locator to redirect packets toward the mobile entity. And the resolution-based approach also stores the locator at the resolution service, but this intermediate offers the locator to the entities communicating with the mobile entity by a resolution service. And the routing-based approach, or routing for short, broadcasts the reachability information of mobile entities and identifier into the whole network so that packets always reach the mobile via the shortest optimal path. And finally, the trace-based approach establishes the forwarding path only along several nodes in the network, and the packets will be first forwarded toward the intermediate and then reach the mobile. For the data dimension approaches, the data depot approach tries to move data from the mobile to a rendezvous point where data can always be retrieved, and the upload process may rely on different host dimension approaches. And for the data spot approach, data is made available around a location where the data may be generated or be retrieved from. After examining the existing approaches, especially the host dimension approaches, we find that where we can improve the performance by considering different ways to deploy the intermediate and to optimize the reachability information update process. And from this starting point, we propose a new dimension in mobility support design space, the knowledge dimension. In this dimension, various types of information, including current states, predictable states, and task-specific strategies, are used as the knowledge to drive the network to satisfy stringent performance requirements. And so the new mobility support solution space can be depicted as a three-dimensional space inside of the two-dimensional space, where two knowledge-driven approaches in the knowledge dimension can be combined with the host dimension approaches to further improve the mobility support performance. So this is the first knowledge-driven approach, namely the topology-driven intermediate positioning, or TIP for short. TIP tries to place the intermediate at an optimal network location so that the forwarding path can be optimized. As seen in this picture, when the intermediate is at A, the forwarding path is a triangular path that stretches all the way to A. So the information about the network, including topology and where the mobile and the corresponding node is at, is fed to this knowledge plane, which produces, using the TIP strategy, produces an optimal location for the intermediate to be deployed at, and sends instructions to actually deploy the intermediate at C, which is the optimal location. So that after the intermediate is at C, the forwarding path is now BCD, which is a shorter path than before. For the second approach, the trajectory-driven reachability update approach, or TRU for short, tries to optimize the reachability information update process of each host dimension approach, so that this process no longer relies on the propagation of signaling packets. As shown in the picture, consider a vehicle moving along a road so that traverses 3 access points at T0, T1, T2 to remove the dependency on the propagation of signaling packets, the topology, the movement track of the vehicle, which can be deduced from the type of vehicle and the road information, and also which underlying host dimension approach is adopted, is fed to the TRU strategy so that it can schedule each access point to update its fib automatically at different time points, so that the information will always point to the current location of the vehicle, but no signaling packets is needed during the locations. Next, we introduce our evaluation framework. Our framework takes a metric definition and architecture and approach description as input, and outputs the formula for each metric. And with this formula, the metric values can be further calculated by being fed with the topology and the movement track, so that the mobility support performance of different approaches in different architectures, or in other words, the different combination of approaches and architectures, can be quantified by performing numerical simulations. So we have defined 5 metrics under 2 scenarios, which will reflect user experience and network overhead. In the basic scenario, we define the path stretch, handover delay, traffic, and state. And in the compound scenario, the upload scenario, we define a time metric, which reflects the time it needs to finish the uploading job. When we examine different approaches, we find that the major difference between each approach is that depending on where the reachability information is updated, the actual forwarding path can be different. It may either be an optimal path or be a triangular path. And when examining different architectures, the major IP and NDN share a commonality that they're both packet switched and rely on FIP for forwarding. So one trying to calculating forwarding path is it's the same between IP and NDN. However, the major differences are, first, NDN natively supports consumer mobility, so we do not consider it here. But NDN producer mobility is rather similar to IP mobility since both interest and IP packets are forwarded according to FIPS. But the one difference is that NDN nodes may retransmit interest on their own because NDN adopts a stateful forwarding process, as shown in this picture, that when the interest times out because it's been forwarded to the previous location of mobile, it can be retransmitted by the in-network node A when the new reachability information is available. So for KD approaches, both TIP and TRU share one commonality. They don't change how each approach is architecture independent. But the difference is that the TIP obviously cannot combine with the routing because there is no single intermediate to relocate. And also, TIP only changes the location of the intermediate, but does not change how forwarding path or signaling packets are propagated, while TRU does affect how each metric is calculated, or in other words, the formulae, because it actually changes how reachability information is updated. So we'll give a brief introduction to explanation to how each formula for each metric is produced. So for stretch, the major consideration is that for proxy and trace, a triangular path is almost always generated, and the actual path is relevant to where the intermediate is. While considering the KD approaches, neither KD approach changes how the forwarding path should be deduced from the position from the network location of the mobile, the intermediate, and the corresponding node. And for the architectures, since both IP packet and interest packets are forwarded according to the FIP, the way to deduce the actual forwarding path is irrelevant to the architecture. And for delay, for different approaches, the delay is determined by how the signaling packet is propagated and also how long the actual forwarding path is. Considering KD approaches, TIP is irrelevant because still it doesn't change the way each approach works, while TRU eliminates the signaling traffic propagation that should reduce the time it takes to resume communication. And for architectures, because NDN allows in-network retransmission, thus the delay should be smaller for routing and trace because the FIP is updated in these two approaches. And for traffic, the largest amount of traffic is generated for routing because it broadcasts the signaling packets, and the traffic will be proportional to the number of nodes in the network. And for KD approaches, TIP is still irrelevant, while TRU, because it does not rely on the propagation of signaling packets, so it completely eliminates the traffic, except for resolution, because the query still requires exchange of packets. And for architecture, the traffic is architecture independent because the propagation process of these packets is not specific to any architecture. It's the same in both IP and NDN. And for state, we consider both mapping as in proxy and resolution, and also FIP entry as in routing and trace as one state. For KD approaches, neither approach changes what and how states are stored, so they are irrelevant. And for each architecture, the difference also does not affect the calculation of state. Finally, for time, we briefly introduce how the final formula is deduced. For this compound scenario, this metric is also compound in the sense that it's based on how stretch and delay is calculated. So first, we determine when the upload is finished and calculate the elapsed time by accumulating all the previous stay period and the actual time used to upload data in the final stay. And thus we get a total time it takes to upload all the data. And for our evaluation, the experiment setups are given as follows. We pick 3 types of topology: the rocket fuel topology, the balanced tree topology, and random graph. We also use 3 movement patterns: the completely random pattern, where the node simply moves randomly from side to side, randomly from a node to node, and local pattern, where a mobile prefers the nearby nodes, and the power law pattern, where the mobile prefers several frequent locations. And we evaluate each architecture and approach combination, including the KD approaches, and conduct multiple random experiments with different seed settings to use the average as the final value. And for results, for stretch, it can be seen that proxy has the worst stretch, while TIP significantly reduces the value for the stretch for proxy and trees by 48% and 90% respectively. And for delay, also the best result is on routing and trace, especially for routing and trace in NDN because of the in-network retransmission. But we also see significant improvement with TIP and TRU, especially for actually for almost all the approaches. We can see over 50% reduction, which is an improvement when both TIP and TRU are used. And for traffic, still TIP leads to average 40% reduction, and TRU completely eliminates traffic except for resolution. And for state, only trace is affected by state because it considers where the intermediate is and reduces the value by 9% TIP. And finally, for time, both TIP and TRU significantly optimizes proxy and resolution, which is consistent with the result for stretch and delay by over 40% under the balanced tree topology. And a brief analysis of optimization effect of KD approaches, we can see when both are used, there will be a more significant improvement, and generally reaching around 50% for most metrics. And that is our research and our result. And our conclusion is that we have primarily demonstrated the effectiveness of the proposed knowledge-driven vision. For our future work, we'll focus on 3 directions. First, we want to extend the evaluation framework to cover the knowledge-related cost, which is not evaluated here, and also propose an architectural design to support this new dimension. And finally, try to apply this knowledge-driven vision to new research topics. That's all. Thank you for your time.
Good morning, everyone. Today I would like to present my paper, an efficient energy efficiency power allocation algorithm for space-terrestrial satellite NOMA networks. My presentation will cover the following aspects. The first is introduction, and then the second part introduces the system model and problem formulation of energy efficiency optimization. The third part is Steinberg-Kim formulation and energy efficiency optimization. Then the fourth part gives the simulation results and analysis. And finally, summarize this paper. Second one is introduction. Firstly, I would like to introduce the mobile accumulation network. With the promotion of massive mobile terminal devices, the whole number of devices linked to the global mobile communication network will reach 100 billion in the future. Satellite networks can be used to supplement terrestrial networks access. The terrestrial network and the satellite network are integrated to supply services for terminals. NOMA has been proposed as a forward-looking multiple access technology for future wireless communication network. In NOMA system, the channel results can be shared by multi-users to get higher spectral efficiency. Recently, some researchers have focused on NOMA to resolve the resource allocation problem and the space satellite terrestrial network, and have achieved a good performance. Although NOMA can improve the system performance by showing the same subchannel results for multi-users. Applying NOMA in the space satellite terrestrial networks face many challenges. Second tool is system model and problem formulation scheme. A accumulation scenario for space terrestrial satellite networks is proposed, while as satellites and our terrestrial base stations provide service together for ground users. The satellite is equipped with antennas to serve terrestrial users and its coverage, and each base station is equipped with an antennas to serve users under coverage. In the terrestrial networks, NOMA is applied for multi-users. Interlayer interference is considered as a part of additive white Gaussian noise. In this paper, we mainly consider cross-layer interference. Then, the SINR of each user can be expressed as follows, just like equation 1, in which GR is denoted as the subchannel gain between base station R and its TTH user in subchannel N. ICR is the inter-system interference, and IN is called superposed interference. In addition, the ZN indicated the additive white Gaussian noise, and PR denotes the allocated power. On the subchannel N, the capacity for the TTH user surveyed by the base station R is indicated by equation 2. Then, the SINR of the user of satellite S in subchannel M is given by equation 3, in which GS is denoted as the subchannel gain between the user and satellite S in subchannel M. ICR indicates the inter-system interference and denotes inter-system interference from the terrestrial base stations for the satellite users. In addition, the ZN indicates the additive white Gaussian noise, and PS denotes the allocated power. The capacity for the user in subchannel M served by the satellite S indicated by equation 4. Optimization the energy efficiency-based NOMA of the space-terrestrial satellite networks is our target. The energy efficiency maximization of base station R can be formulated as follows. The energy efficiency maximization of satellite S can be formulated as follows. Factor 3 is Steinberg gain formulation and energy efficiency optimization. Steinberg gain. In this paper, the leaders and followers of the system for competition is regarded as the maximization of the system's energy efficiency, in which base stations are followers and the satellites are leaders. In the Steinberg gain, each base station tries to maximize its own energy efficiency. After the base stations make the decisions, the satellite makes a strategy to maximize each satellite's energy efficiency. The iterative calculation between the base stations and the satellite will attain the equilibrium point of Steinberg gain. Problem optimization. In order to make the solution more efficient, the original fraction non-converse function is transformed into a converse form function to get the optimal solution for the proposed problem by Tinkerberg-style algorithm. When the solution of the equation f is got, the optimal solution of the function is also got. While the parameter lambda is set as an adjective variable. Therefore, the power allocation scheme will be formulated on the basis of f. Well, we could convert the optimization problem in the non-converse form as: for solving the optimal power allocation scheme, we introduce the ADMM algorithm. ADMM algorithm is introduced in the follows. The power allocation algorithm-based ADMM for base station is concluded in the following algorithms. 1. And the satellite user's power allocation algorithm has same scheme. Algorithm 2 shows the gain between the leader and the followers. on the wake of the game progresses, and both will attain an equilibrium point. Then, the power allocation scheme will be acquired. Section 4 is simulation results and analysis. We assume the space-terrestrial satellite NOMA networks including 2 satellites with 8 subchannels and 2 base stations with 4 subchannels, and each base station subchannel is shared by 4 users. The bandwidth is 30 MHz, and the carrier frequency indicates 2 GHz. It's assumed that the coverage radius of the satellite is 500 kilometers. Considering the great difference between satellite channel and base station channel, satellite channel is simulated as reach channel. Base station channel is simulated as relay channel. Figure 2 indicates the energy efficiency of different followers under each of iteration. The energy efficiency of each follower increased with the iterations, and the coverage when the number of iterations is about 5. It can be seen that iterative algorithm 1 can remarkably improve the energy efficiency for followers in the subgame. Similarly, this algorithm is also applicable to the leader subgame. Figure 3 shows the energy efficiency in each subchannel for first satellite under each of iteration. The energy efficiency of the satellites is increasing and reaching the equilibrium point. The figure indicates the proposed algorithm can improve the energy efficiency of leaders because of the different allocation of each user on each subchannel. The energy efficiency of each subchannel is different. The energy efficiency in the Steinberg game is obviously perfect. Section 5 is conclusion. Firstly, this is summary. In this paper, the space-terrestrial satellite NOMA network was investigated to maximize system energy efficiency by introducing Steinberg game. The leaders, base stations, and follow satellites make corresponding strategies according to the other parts, strategies to obtain the maximum system energy efficiency respectively. The ADMM algorithm is applied to optimal power allocation scheme in base station layer and satellites layer, respectively. At the same time, the balance between base stations and satellites is achieved by Steinberg game, significantly improves the energy efficiency of the proposed network. Secondly, this is prospect. This paper only investigates the power allocation algorithm based on NOMA. In fact, there are still many resource allocation schemes in wireless communication field that need to be optimized. In the future work, we will continue to focus on resource allocation algorithms, including user association, beamforming, subchannel allocation, and so on. That's all my presentation. Thank you. Is there any questions?
Hello everyone. The article I will talk about is research and equilibrium optimization of AODV routing protocol in ad hoc network. Next, I will explain it from 6 aspects. First is introduction. Second, AODV protocol and working principle. The third, optimization of AODV routing protocol. The fourth, simulation analysis. Fifth, conclusions. In the beginning, I will give an introduction to the routing protocol in ad hoc network. Firstly, ad hoc network is a multi-hop, self-organizing, and self-managing network, which consists of a group of mobile terminals with wireless transceiver equipment. Second, ad hoc network does not need a fixed base station, and has the characteristics of strong survivability and extremely convenient creation and movement. Thirdly, it can be easily and flexibly networked and used in public service, emergency search and rescue, intelligent transportation, and other fields, and has broad application prospects. The role of the routing protocol is to monitor trends in the network topology in this network environment, exchange routing information, and forward data according to the selected route. Ensuring the connectivity of the network is the basis for mobile nodes to communicate with each other, and it is an important core area in ad hoc networks. The figure 1 is classification block diagram of ad hoc network routing protocol. From this picture, we can see ad hoc network routing protocol is divided for 3 parts: proactive routing protocols and unmanned route protocols, hybrid routing protocols. Firstly, proactive routing protocols include DSDV, WRP, and OLSR. The on-demand route protocols include DSR, AODV, and ADR. Hybrid routing protocols include ZRP, SRL, and so on. At present, dozens of ad hoc network single-path routing protocols has been proposed to solve the routing problem in ad hoc networks. According to different ways of establishing routes, routing protocols can be divided into pirate routing protocols and reactive routing protocols. The SDV is a more typical prompting routing protocols, and DSR, AODV, and TORA are more typical reactive routing protocols. Research shows that in case of node movement, the reactive routing protocols has lower routing overhead, and its performance is better than the proactive routing protocols. Among the reactive routing protocols, the AODV protocol has moderate routing overhead and fast convergence. The advantages are obvious. Is one of the promising routing protocols in the ad hoc network, and has become the basis for the expansion of multi-path protocols. In the second part, I will talk about AODV protocol and working principle. First, the advantages and indicators of AODV protocol. Firstly, there is no need to maintain the route table in real time, and only seek routing and update the routing table when needed. The second, the intermediate node can replace the destination node to reply, reducing the delay of the route discovery process and improving the convergence speed. Thirdly, all nodes and information messages have sequence numbers, which avoids the problem of routing loops and counting to infinity. Fourth, it has broad multicast and good scalability. Fifth, widely studied at home and abroad, there are many improved protocols based on AODV routing protocol. Next, I will talk about the working process of AODV protocol, about route discovery. The figure 2 is a reserve route establishment. Firstly, when the source node needs to establish a communication link with the destination node, it must first broadcast RREQ, or say route request, within the communication range. Step 2. The intermediate node will decide whether to forward the RREQ according to whether it is the first time to receive the RREQ, and the destination node will receive the RREQ after it arrives. The figure 3 is forward routing establishment. At last, the destination node needs to reply RREP, or route reply, to the source node. The message RREP will pass through the intermediate node and return to the source node. At this point, the routing path has been established. The working process of AODV protocol about route methods. I divided it into 3 parts. First, nodes periodically broadcast hello messages through the MAC layer to determine the link status. The second, if the node does not receive the hello response message for 3 consecutive times, it is considered that the link has been disconnected. The routing information containing the link is deleted, and the routing is started. Last, the wrong RER message notifies neighbor nodes, and the corresponding upstream nodes deletes routing information, which causes the target node to be inaccessible due to link disconnection. The third part, I will say some optimization of AODV routing protocol. Firstly, I define the initial energy of the I nodes as EI0, and EI is the residual energy of the node. Therefore, the residual energy percentage can be expressed as E equal EI to EI0 in the formula 1. Next, in order to measure the load of the I node, we define NI0 as the original maximum volume of the data buffer Q of node I, and Ni as the data length in the remaining data buffer of node I, so as the ratio of the two can be written as N equal Ni to Ni0 in the formula 2. The third, routing overhead is determined by load and node lifetime. We can estimate the routing cost of the node through the parameters derived from Formula 1 and Formula 2. Set the weight of left circle and log to alpha, and the number of nodes to d. Then the routing cost of a node can be expressed as Formula 3. It can be seen from Formula 3 that the routing cost comprehensively considers the remaining energy of node and the congestion of the path. We can choose the appropriate path according to the actual situation. About optimization of route methods, is a problem. After receiving the notification of the broken link, the source node will restart the route discovery process and establish a new route. However, the establishment of a new route will also lead to an increase in network energy consumption, thereby interrupting the link. We have two solutions to solve this problem. Solution 1. If the remaining energy of a node in the network is small, say less than a certain percentage of the remaining energy of the largest node, or the load is too large, the node will broadcast the RRER and the upstream node will immediately delete the broadcast RRER and select the node as RRER. The routing link of next hop at this time, this can be transmitted through the alternate route. The solution 2. If there is no backup route, the node is the only one. Repair RREQ from the last hop node to obtain new routing information. If no new route is found, the route will eventually be rediscovered from the source node. This method can greatly reduce network delay and routing overhead. The last part, I will give simulation analysis. Simulation says, first, we set 50 nodes in a space of 800 meters square. The node's moving speed is between 15 and 20 meters per second. The effective wireless transmission range is 250 meters. The packet transmission rate is 1 packet per second. The value of alpha is 0.5. The critical value of routing cost is 10%. The simulation time is 600 seconds. These parameters are used to compare the performance of traditional AODV and EAODV routing protocols. So we do some simulation analysis. Figure 1 is the total energy consumption. From Figure 1 shows that the energy consumption of both protocols increases as the number of nodes increases. But the total energy consumption of AODV is always higher than that of EAODV, because the EAODV uses the multi-path routing mechanism optimizes, and the original route reduces the flooding of the original route, and also reduces the route cost and the total energy consumption. The Figure 2 shows the number of dead nodes. We can see from Figure 2 that the number of dead nodes increases as the simulation time increases. The number of dead nodes under the AODV protocol is significantly higher than that of the EAODV protocol, and the gap between the number of dead nodes under the EAODV and AODV protocols at different times is getting bigger and bigger. This is because the EAODV protocol balances network overhead through node energy and load. The last part, we give conclusions to this passage. Firstly, due to the defects of AODV protocol in ad hoc network, we finally proposed a new AODV optimization protocol EAODV. Second, in the process of establishing the link, we comprehensively consider the remaining energy of the node and the load of the node. Maintain the optimize the multi-protocol network by deleting nodes with lower routing costs. Third, the simulation results show that compared with original AODV, the EAODV protocol can reduce the total energy consumption and balance the network overhead. Moreover, the scale factor can be freely selected according to the situation to adapt to more network environments. Thanks for listening.
Hi everyone, this is Susuyan. Currently, I'm a graduate student in Harbin Institute of Technology, and today I'm gonna introduce my paper, which is Campus Bullying Detecting Algorithm based on surveillance video. And the main content of this presentation is constructed as follows. Section 1 shows the background. Section 2 introduces the boom point detection. Section 3 describes feature extraction. Section 4 gives out the classification result by simulation. And Section 5 draws a conclusion. First, I'm gonna talk about background. Campus bullying has caused great harm to society and education in many countries. In many school bullying cases, the students hide the fact that they were bullied because of fear. They don't inform their parents or teachers in time, which led more and more bullying. As a result, bullying students had a serious psychological trauma. The research of deep learning and computer vision are more and more mature. However, most application scenarios of computer vision are limited to industry, transportation, and commerce. It is known that there are relatively few researchers who are researching on the application of campus scenes. The Keynight device developed by the Microsoft can capture the dynamic pulse of two-dimensional. However, the system is highly dependent on the Keynight device. It increases the hardware cost of the system, so the main purpose of this study is to design the bullying detecting method based on open pools. And I will introduce the structure diagram. The diagram of this study is shown in the figure. First, we use the surveillance camera to capture video. We detect the bone point of the human body in the video. In the end, a simplified skeleton structure is formed. Next, we process the coordinates of the joint points. We extract the features that can represent action and use classifier to distinguish actions. Finally, we completed the detection of campus violence based on the video surveillance. In this study, bone points are used to identify the human action. Bone points represent the position of human in two-dimensional coordinates. It not only shows the local shape of human, but also describes the topological information. Therefore, it is of great significance to use the bone information of human to recognize action. As shown in the figure, this study used 18 key points to build the skeleton model. The label of the bone points is shown in the table. Next, I mainly focus on talking about the bone point detection. The traditional action restoration algorithm is to detect the human object first. Each target gets an edge box. For each box, the method completed the human pose estimation of a single person in turn. And finally, all human action in the image are restored. The method belongs to top-down detection. However, the accuracy of this method depends on the result of human target detection, and the speed of the algorithm is proportional to the number of persons in the image. The model uses a deep neural network to extract the original feature map of the image. For the input image, OpenPose first used VGG19 to extract the feature map. OpenPose uses a two-branch convolutional neural network. The prediction result of the previous stage is fused with the original image as the input of the later stage. The purpose is to improve the prediction accuracy in order to avoid the disappearance of the gradient. The loss function is added at each stage. And then the model input is divided into two branches. In one branch, a convolution neural network is used to predict the heat map of joint points. The maximum value of the heat map is the coordinate of the key point. As shown in the figure, when there are only one person in the image, there are only one peak at the joint points in the heat map. In the other branch, another convolution neural network is used to obtain partial affinity domain of all the connected joint points. The pixels of the domain are represented by the two-dimensional vector. Two-dimensional vector is composed of position and direction information. It can be seen from Figure A that the distance between the left elbow joint of the B and the left head of C is the smallest. If the minimum distance is used as the standard of joint point connection, they will cause division error. We add direction information based on distance. The effective key pair not only has the smallest distance, but also has the same direction as the affinity field. As shown in the Figure B, each lamb has an affinity region. In addition, Figure A shows the result of the single action restoration. We can get the restored human skeleton by connecting the key points of the bone. Figure C shows the result of multi-person action restoration. The heat map has multiple peaks. This represents the same type of the bone points of different people. In Figure D, we can see that the heat map has two peaks, which represent two boiling points of the same type. Campus bullying is commonly attended by multiple persons, and the interaction of these persons is relatively strong. Therefore, we use circumscribed rectangular frames to separate different persons in one image. Figure A shows the circumscribed rectangular frame target separation, and Figure B shows the bone analysis. Next, I'm going to talk about feature extraction. Feature extraction is an important step in human action recognition. First, we catalog the collected video samples. Violent behaviors are regarded as boring and marked as positive samples. Daily life behaviors are regarded as no boring action and marked as negative samples. There are totally 83 positive samples and 118 negative samples. Motion features can be expressed as a coordinate information of human joint points. In this research, both static and dynamic features of human bodies are extracted for Boolean recognition. The number of the features we extracted is 27. The specific characteristics are shown in the table. In addition, for classifier, we work with Vocational support vector machine. As mentioned above, label the feature sequences extracted from campus Boolean fragments as positive and those from daily life action as negative. Thus, this study is two-class problem. We choose support vector machine for classification. Based on the minimize loss function, it looks for hyperplane to distinguish samples for a different class. I mainly focus on talking about evaluation index of classification model. We use five-fold cross-validation to estimate the classification performance, and Table 1 shows the configuration matrix. Then, we calculate the four indexes of accuracy, position, recall, and FE score. Table 2 shows the result. Finally, campus Boolean detection algorithm gets an average accuracy of 88.57%. Finally, I meant to summarize my paper into the following points. First, we use the open pose model to extract the human bone point in the video. Then, we use the coordinate of bone point of two extracted features. Support vector machine is used to classify violent action. Moreover, video can facilitate manager to confirm the occurrence of violence. Finally, the method gets an average accuracy of 88.57%, which shows the promise for the detecting campus Boolean events with the surveillance cameras. Okay, finally, thank you for listening.
Hello everyone. My paper title is The Applications and Drawbacks of Emerging AI Framework in Online Education Field. My name is Ming Jiang. I'm from Harbin Institute of Technology. The contents of my paper include 4 parts. Artificial intelligence is a technology that studies, simulates, and expands the theory of human intelligence and related methods and applications. It simulates human intelligence through computers and finally makes it think, learn, and recognize like humans. In recent years, due to the penetration of artificial intelligence in the field of education, the ecology of education has undergone profound changes, which has received widespread attention from all over the world. It has been raised to the height of national strategy by all countries in the world. The application forms of artificial intelligence in education industry are mainly reflected in the following 5 aspects. Intelligent evaluation, intelligent tutor, educational simulation, educational robot, and mixed reality education. The emergence of educational robots has brought great changes to education and teaching. Educational robots liberate teachers. On the one hand, educational robots can replace parts of teachers' work, free teachers from tedious teaching tasks, and pay more attention to students' emotional development and moral cultivation. On the other hand, the robot can be used as a teacher's assistant in teaching. Online autonomous learning platform can evaluate students' learning situation according to students' historical learning data, predict students' future learning performance, and intelligently recommend the most suitable learning content and learning method for students, so as to effectively improve learning efficiency. However, at present, autonomous online learning platform mainly focuses on the development of teaching content and curriculum. It ignores the development of learners' thinking ability and cultivation of their emotions and lacks teaching students according to their aptitude. MR technology includes augmented reality technology and augmented virtual technology. This technology introduces reality into virtual environment. It establishes the connection between virtual and reality, and users can interact with information loop in real time, so as to increase the sense of reality. MR technology can be combined with most disciplines and specialties to improve the efficiency of knowledge transfer. AI education are faced with the problem. Although AI has an exciting potential in education, there are still many problems to be solved. For example, context sensing technology in AI is not mature, and there are dozens of technical problems to be solved in AI system. In the application field, the integration of artificial intelligence technology and education is not close enough. At present, most products focus on a single narrow adaptive learning field and pay less attention to students' growth, comprehensive ability development, and physical and mental health. The first problem of artificial intelligence is lack of humanistic care in teaching philosophy. At the level of technology application. AI education pays too much attention to the rationality of technicalism, ignores the purpose of promoting human development by applying technology, uses technologies for the sake of technology, and ignores the essence of education and the environment of educational development. At the level of personnel training, education ignores the cultivation of people's internal quality, which leads to the lack of people's taste. Education involves the cultivation of human quality and the shaping of human soul. It is hard to learn truth, goodness, beauty, and morality by machine alone. At the level of teachers, intelligent machines gradually replace teachers, but no one carries out teaching activities, which may lead to the lack of humanistic care. The second problem of AI is teaching content relies too much on big data support. Theoretical aspect. The theoretical support of big data technology system is probability theory. It is effective to understand and master the education laws and methods from a macro perspective, but it is not helpful for personalized teaching, which is also the limitation of big data. Practical aspect. The quantity of education big data is limited, and the quality needs to be further examined. So the teaching content selected by big data needs to be further examined. The third problem of AI is the teaching form is solidified in the old exam-oriented education structure. To a certain extent, the development of AI education fails to break through the shackles of examination-oriented education. The specific performance is as follows. Through the application of big data, a large number of people with certain technology or knowledge have been cultivated in a short period of time. On the surface, it seems that the teaching objectives, teaching methods, and teaching contents have been changed. In fact, this batch training mode has no essential difference from the traditional exam-oriented education. The application of new technology does not change the old structure of exam-oriented education. It's the same thing. The fourth problem of AI is there are interactive limitations in the teaching process. At present, due to the limitation of technology, AI can't communicate completely with natural language, so the teaching process is still a process of unilateral knowledge output to students, and it is difficult to realize AI education like teachers. In addition, it is difficult for AI to fully understand the students' emotion, attitude, and values. As a result, there are interactive limitations in the teaching process, which is also an important embodiment of the low degree of integration of AI and education, which seriously restricts the completion of the teaching process. The fifth problem of AI is AI education ethical issues. Ethical issues include 6 parts. The first is the fuzzy boundary between AI and educational subjects. The second is the alienation of algorithm recommendation and students' personality development. The third part is emotional crisis of human-computer interaction. The fourth part is privacy infringement. The fifth part is data leakage. The sixth part is technology abuse. The deep integration path of artificial intelligence and education. It includes three parts. First, remolding the educational idea and training the comprehensive quality of workers. In the industrial society, it is based on the production of large machines, which requires people to have IQ and deal with the relationship between people and things. In the information society, with the adjustment of industrial structure, the proportion of the tertiary industry has increased, people's work has changed, and the technical content of their posts has changed. Therefore, it is not enough for workers to only have knowledge, but also need to interact effectively with users and learn to get along with people. EQ is in the middle of pyramid as an important part of the quality structure of workers in this period. In the area of artificial intelligence, we should not only have IQ and EQ, but also learn to deal with the relationship between human and machine. The relationship between education and artificial intelligence is to have AIQ. That is artificial intelligence quotient. Multiple construction of education plus artificial intelligence ecosystem. Enterprises, schools, governments, and scientific research institutions should construct education plus artificial intelligence ecosystem, including optimizing ecological environment, innovating teaching mode, improving teaching level, reforming teaching evaluation, and ensuring the dynamic balance between education plus artificial intelligence ecosystem and economic and social system. Optimized education plus artificial intelligence support system. There are three parts. First, national policy is an important guarantee to promote the deep integration of artificial intelligence and education. Second, financial support is the prerequisite for the inclusion of artificial intelligence and education. The second, introducing market mechanism. Conclusion. With the development of artificial intelligence, it has reached or advanced human level in the fields of image recognition, speech recognition, and natural language processing. Through the study of a large number of samples, AI has mastered the essential mechanism of human thinking mode and contains great potential. Although AI still faces challenges in education industry, the development of AI will have a profound impact on the field of education. Thank you. Thank you for your attention. Goodbye.
Hello everyone, it's my great honor to be here today to share with you about artificial intelligence education. Here is today's list and I will start in the following order. Now, here we go. In recent years, led by the way of artificial intelligence, artificial education has become a very hot topic. More and more traditional education institutions has begun to organization layout field of artificial intelligence education. Here are 4 questions about today's topic. What is artificial intelligence? What is education? What's the difference between artificial intelligence education and traditional education? What is the relationship between education and artificial intelligence? And there are 4 questions answered in the scheme. So, with the out of the way, we do employ AI means education. One, make the traditional roles more intelligent. 2, open education environment. 3, improve the quality of teaching. Is 3 significant in artificial intelligence in education. So, what can we do? The mean for the artificial intelligence education application. 1, smart assessment. 2, smart tutoring systems. 3, educational simulation game. 4, educational robot. Next, we look at the advantage and disadvantage of artificial intelligence education for different processes in the case. The application of artificial intelligence for the perspective of learning is that the application of artificial intelligence for the process of is broadened and reduction. The application for the artificial intelligence for the perspective of learning moves. The problem following artificial intelligence education about following 4 aspects. One, artificial intelligence education technology upgrades. 2, learning mode simplification. 3, limitation of artificial intelligence education interest. 4, the source of artificial intelligence is limited. The research staff. The research staff following 4 aspects. 1, national priority support. 2, research and development both at home and abroad. 3. The market share of artificial intelligence education continues to increase. The promotion of artificial intelligence education enterprise. 7. Future developments and development direction. With the development of artificial intelligence education in variety industries, there are a variety of problems which may have a process of future of the education. AI education is not a thing totally of single technology. The way artificial intelligence education should be combined with advanced science and technology is consultative and development the educational teaching achievement. Therefore, we expect to introduce mixed relative technology in artificial intelligence, adapt education to improve the grades in education. Thank you for your watching. Hello everyone, it's my great honor to be here today to share with you about the future development of education in the era of artificial intelligence. Here is today's list, and I will start in the following order. Now here we go. There are 3 questions about today's topic. What kind of application does artificial intelligence have in the field of education? 3. 2. What role does it play in education? 3. What's the impact? Two aspects. Researching background of the artificial intelligence education. In the traditional training environment, most of our traditional education for still stay in the stage of exam-oriented education. We ignore the high level ability and knowledge application outside the memory. The high cost and low efficient experiment training outstandard. The classroom also added a great economy burden to present. So it has become an urgent need to intelligent artificial with education. 3. Application of artificial intelligence in education. There are 4 aspects in application of artificial intelligence in education. 1. Intelligent tutoring system. 2. Intelligent network examination system. 3. Intelligent discussion support system. 4. Intelligent simulation technology. So the role of artificial intelligence in teaching. There are 3 aspects about the role. Artificial intelligence makes traditional classroom more intelligent. 2. Start high quickly teaching resource across time and space. 3. In the open education environment, the educational sense is no longer limited to the classroom. 5. Research start and development of artificial intelligence education. Artificial intelligence has developed for more than 6 years. It's we used to in all works in our life, especially in education industry. Companies are using AI technology and big data can help students learn and explore personalized education. Well, in this way, the teaching and practice teaching will become a reality. Thank you for your watching.
Greetings, respected professors. My name is Yu Yang, and I will make a presentation for my paper, Dormitory Management System based on face recognition. My presentation can be divided into the following 4 parts: the background, the work methodology, the main achievement, and the conclusion and future work. First, I will introduce you the background. At present, with the rapid development of artificial intelligence, the era of AI has quietly arrived, and showing your face has gradually become a new trend. With the higher demand of quick and accurate methods of verification, face recognition is becoming more and more common. The purpose of this paper is to find a quick and accurate method which do not have the demand of systems with high performance, to manage students' dormitory in a fast and efficient way. It has 3 parts as follows. First, the face recognition module. Second, the database module. And last but not least, the UI and software module. The final purposes of these systems are shown here: less storage, high speed, and high accuracy. Part 2 is the work methodology of my paper. First, the face recognition module. The face recognition module contains 3 little modules: the face recognition and interception module, the face alignment module, and face verification module. The traditional method, called histogram of oriented gradient, is used to detect and intercept a face in the picture. The face alignment module is based on the deep learning library. According to the 68 points face landmarks, by finding and multiplying a similarity transformation matrix, the face features can be aligned to the average face. FaceNet neural network are adopted to extract 128-dimensional feature vector of face, and then we can store it in the database or compare it with face in database and calculate Euclidean distance so as to compare the most similar person according to this distance. The network structure called FaceNet is used in this system. The biggest innovation of the network should be proposing a different loss function. What's more, instead of using a classifier, we use the distance of points in the agent space to indicate whether the 2 images are the same class. The network structure is shown as Figure 1. First, batches are sent to a deep architecture, such as a convolutional neural network. Google Inception ResNet V1 is selected here. Second, after CNN, each feature X, each image feature X should be L2 normalized so that the feature of all images is mapped to a hypersphere. Then send the feature into an embedding process so the image X is mapped to 128-dimensional Euclidean space by function fx. Last, after the embedding layer, we optimize the weight of CNN with these features, and here we propose a new loss function, triplet loss function, which is the biggest innovation of the network. Figure 2 shows the learning method. The triplet loss function is a loss function with 3 sample inputs, containing an anchor sample, a positive sample, and a negative sample. By training the classification model with LDA method, the intra-class feature distance is getting closer and the inter-class feature distance is getting far away. In order to ensure that the feature distance between the anchor sample and the positive sample is closer and the feature distance from negative sample to the anchor sample is farther, we need the triplet loss function to realize it. The triplet loss function here is listed on this page.
Mr. Chairman, ladies and gentlemen, good morning. Thank you, Mr. Chairman, for your gracious instruction. My name is Zhang Ling from City College of Huizhou. The title of my presentation is Factors Affecting Students' Flow Experience of E-Learning System in Higher Vocational Education using UTAUT and Structural Equation Modeling Apertures. I'm going to give this talk in 4 parts. First, the instruction and hypothesis. Second, the methodology. Third, the finding and discussion. And the last, some conclusion we have got. In the past few years, many e-learning systems have adopted technologies such as artificial intelligence and big data. The e-learning system has gradually become a smart education platform. For example, the e-learning system of our school, used by more than 700 teachers and more than 20,000 students. Our e-learning system has more than 3,000 courses. The course resources are rich in categories, including videos, pictures, documents, web links. Our e-learning system makes use of some technologies such as AI and big data. The interaction between teachers and students is simple and convenient, and the list and recommendation of teacher resources become easy and easy. However, the absenteeism rate for some courses exceeds 47%. At the same time, the maximum number of active courses is only 1726. Do we understand the actual learning effect of students? Do we understand the students' behavioral intentions? How to promote the flow experience of students? Every student has different characteristics. Only catch the key factors that affect students using e-learning system. Smart education technology can promote students' learning effect. This research will bring new ideas to teachers and managers. Finally, it will give more benefit to teachers and students. According to the research of circulars, someone in a field state only have goals and activities. Forgot all the others. The UTAUT model was widely used to analyze the user's behavioral intentions when students use e-learning system. What are the key factors that affect their flow experience? What are the key factors that affect their behavioral intentions? Behavior intentions, performance expectancy, effort expectancy, cycle influence are important variables of UTAUT. Validating conditions perceived usefulness have a positive influence on behavioral intention. When people are staying engaged in tasks or activities, people feel happy and enjoy it. People enter the state of flow experience. Therefore, in this study, we supplement the UTAUT model with flow experience. We use the new model to explore the behavioral intentions of high vocation students. Try to find key factors that affect their flow experience and behavior intentions, taking the students of high vocation schools as the research object. Explore the possible influence factors those students using the e-learning system. We propose can hypothesis. To hypothesis will explore possible letting effect. As shown in the research roadmap, we will construct questionnaire design and recap, measurement model analysis, and structure model analysis. In measurement model analysis, we will measure reliable and convergence validity. In the structure model analysis, we will implement the path config. We will implement the path, conflict, and hypothesis test, model interaction analysis, importance and performance analysis. In the analysis phase of measurement model, in the measurement of reliability and validity, the indications including compass alpha, composite reliability, average variance is checked, and factor loadings in the common native validity. The indications including cross loadings, falling, and rocker. We will use the PRS algorithm function. Domain methods of structural model analysis are path, confidence verification, hypothesis verification, model prediction ability verification, and IPMA verification. Indication including path value, t-value, p-value, specific effect, R-square value. We will select the bootstrapping module. We will select the bootstrapping module. Select 5,000 bootstrap samples. Obtain the path configuration, t-value, p-value, and other indications of parameter such as R-square. Obtain delight effect, indirect effect, and total indirect effect. The questionnaire including 38 questions. Use the 5-pole line force scale at the stand time. 2 indications are added to the latent variable PU. We found that CR greater than 0.7 compass alpha greater than 0.7 AVE greater than 0.5 for all indications, but SI was not acceptable in the Bernal locker table and the closing loading table, and EE1, EE3, and EE5 with VIF greater than 5 and the FC7 with VIF less than 2 will remove as the variables will remove the EE1, EE3, EE5, and F7 because there were 7,645 complete answers, so the questionnaire response rate is 97.8%. The sample met the requirement of the result. Equation model Smart PS3. See Chapter 1. CR BE equal 0.96 EE equal 0.95 FC equal 0.95 FE equal 0.93 PE equal 0.93 PU equal 0.95. Meet the requirement of recommended index. Compare alpha BE equal 0.95 EE equal 0.93 FC equal 0.94 FE equal 0.9 PE equal 0 PE 0.91 PU equal 0.93. Met the requirement of recommended index. LVE BE equal 0.75 EE equal 0.8 FC equal 0.79 PE equal 0.83 PE equal 0.78 PU equal 0.94. Met the requirement of the recommended index. All factors loading more than 0.7 meet the requirement of recommended index. These control reliability and control variability were accepted. See Table 2 and Table C. The square law means all LVEs in the table is exceed than its correlation with other structure. The index low on each construction in Table 2 is higher than that of its corresponding construction. Therefore, the discriminative validity or modified model met the requirements. See Table 4 and Table 5. All hyperlinks are supported, especially H9 is confined. Especially H10 is also confined. The VAF of FCE to FEVBE equal 0.24. The VAF of PU to FEV over PE equal 0.26. So H9 and H10 have potential so H9 and H10 have potential mediating effect. See figure 2. The results show that BE, FC, and PU have experienced 71% of the valence of FE, EE, FC, PE, and PU explain the 18% valence of BE. This model is acceptable. See the result of IPMA. PU, FC had importance and high performance to the flow experience. PU and FC had high importance and high performance for FC and BE. We use flow experience as a target variable to supplement UTAUT model. We use a new modern and structural equation modeling of apertures. We disclose the factors affecting students' flow experience of e-learning system in high vocational education. The model can predict 71% of FE. The model can predict 81% of BE. The key variables that affect the performance and importance of FE are PU and FC. The promoters are PE and EE. So we suggest dangers, managers, teachers may need to pay attention to the key factors such as PU and FC to promote students' flow experience. The sample may instruction bias, but covers almost all students in the 2 grades of the school, so it can represent the views of students in basic Vocational college. In future research, we will add new variables to exchange the model. New variables include new habits, new motivation. We will continue to use the research result of behavioral intentions and follow experience to improve the application effect of smart education technology. That's all for my presentation. If you have any questions, please feel free to contact me. Here is my email address. That's all. Thank you.